Anyone else wanting the tubes? Which one would you want? This one. This one is work energy power. Measurement මේ ඕක තියෙනවනේ පුතා. ඕක දැන් තියාගන්න මේක නෙමෙයි මේ area වලින් tip ටික මම දෙන්න වෙනවා. Right. So I gave you some homeworks, I guess. Have you started? Yeah. Right. So guys, I hope for the online people now already the tubes have arrived. Some people texted me that the tubes have arrived, and not sure if some have arrived yet. They already sent. Like, can you tell if the tubes are not arrived yet or not? Right. Sairu, it's not yet. Shiny, you have, right? Shiny texted me that she got it. Sairu still, but I think Shiny is far away. Then will arrive most probably on today, Bata. Right. So I gave you some homeworks, didn't I? I did. Yes. Take out the homeworks, bros. Now where are the homeworks? Now what is this? Area volume homeworks. Where? What happened to your hand? Aragi Sati. Either you take, like, listen, right? When you're answering the question of the tiodes, you can you can select either one of the two selections. One is you take a separate book for that, right? When you're taking a separate book, you have to write the tiode, the page number, and the question number, and keep it very clear, right? And the other one is you take a separate paper, a rough paper, and you put all the answers there, and you attach it to the certain paper that the questions are there. Right? පොතක් ගන්නනේ සමහර කරාට පේපර් එක ලියලා තිබ්බම සමහර ළමයි එහෙම කරනවා. එතකොට ටක් ගාලා පෙරලනකොට තියෙනවා. එහෙමත් ලේසි නැත්තම් පොතක් ගත්තක් කමන්නේ. කොහොම හරි you'll have to have a clear questions answered like the question and answers like clearly should be there, because when it gets closer to the exams අර මේක panic වෙන්නේ නැතුව ටක් ගාලා answers ගන්න පුළුවන් විදිහට හදා ගන්න. Then it will be මයින්ඩ් එකට අවුලන්නේ නැත්තම් අන්තිමට කියනකොට ප්‍රෙෂර් වෙනවා. දැන් ප්‍රශ්න තියෙනවා උත්තර නැහැ. How do you get into the answer? මොන රෙද්දක්ද මේ? ඔන්න ඔය හිතනවා. හරිද? Definitely you will get the feeling. හරිද? ඒ හින්දා have the answers clearly written either in a paper or a book and keep it until the exams finish, right? එතකොට කිසි අවුලක් වෙන්නේ නැහැ. The girls are requesting something. Bro, like, උස වැඩි පේන්නේ නැහැ කියලා කියන්නේ. Take a shift. The guy in the middle. Bro, take a shift. අවුලන්නේ නැද්ද? right. ඔයා එන්න පොයි. ඔයා අවුලන්නේ. Yeah, okay. Right. So, did you all do the homework? Yes? No? No, why not? ඒක homework කරා පොතකින් බැලුණා. ඒ පුතේ පොඩි කාලේ කියව බොරු ඒව දැන් නම් කියන්න එපා. ඇයි රෙකෝඩින් එක මම දානවනේ. කරාද? Yes. කවුද? මම? නෑ.
ඊශාන් රණවීර මිස් ඊශාන් රණවීර රිමූව් මේකෙත් අයින් කරලා දෙනවා. මේකෙත් අයින් කරලා දෙනවා. නෑ ඒකට ඇඩ් කරලා හරි. මේකෙන් අයින් කරලා දෙනවා.
That's 2026. I think නුගේ කොටවා. You don't come there no?
ඒක මේ homework කරන්නේ අපිට නෙවෙයි කරන්නේ.
ඒක වැරදිලා උකට දාලා තියෙන්නේ. ඔය 26 එකේ එකක් නෙමෙයි 27 එක. ඒක වැරදිලා දාපු එක.
මේක කරන්න ඕනේ කොහොමද?
ඔව් ඒක උනාට 27 එකේ එකක් නෙමෙයි. 27 එකට ඔක මම වෙනම දැම්මා. දාලා තිබ්බා. ඇයි අර වයිස් පාත් එකේ ගෲප් එක? මමද? නෑ. Now this is separate class. I arrange you like it will start on next month. Yeah, someone else is doing it. School එකක් විතර officially දැනට තියෙන්නේ සයිඩා විතරයි. කේරි එකේ දැන් කීප එක කේරි එකේයි තව ආපහු මහරගම තියෙන මොකක් හරි ඉන්ටර්නැෂනල් එකයි තියෙනවා කියලා ආරංචි වෙනවා. But I'm not confirmed about those. But the Zaira is the confirmed school. Like it is for sure is there. Can start. Now that's the thing, right? You can, guys, listen. I don't think, right? Now the trouble is this, right? So you can request from the school if they provide the papers for your exam only. And they'll be teaching in Sinhala medium that you can request. And some, like there are some of the students who are still like attending their school in Sinhala medium, but they're requesting the papers in English medium and they'll be doing the final exam in English medium. And that's fine. Or else, like there are few schools, those who have like already started the English medium, which are like Zaira is there for the boys school. And few of the other like private schools also have started the English medium, as far as I know. Like I heard like one KD have started that, they said, and one of the international school near to the Maharagama also have started the English medium like technology class there. So either you request from the like the certain school that you are going to have the papers in English medium, but you be still attending the Sinhala medium class, or else you attend one of the schools which already have the English medium, or else you come to the class, you learn here and you face the exam and get a good result. You can do any of that. That's your choice, right? And whatever you be doing, I'll be supporting. Just tell me and I'll yes. මොකක්ද right, now come to the measurements today, right? Come to the measurements today. We're starting the measurements, right? So we're going to discuss the micrometer screw gauge first, right? So we are to discuss the traveling microscope, but I'm going to skip for a moment the traveling microscope and going to continue from the micrometer screw gauge, because these two concepts are like the majority of the questions will be coming in these two parts. What are the two parts? The vernier caliper. The vernier caliper is one. The other one is micrometer screw gauge. What are you taking pills? Concentrating pills, right? So those two parts will be there in your papers, like the proper paper that you will have in your A levels. Will have more questions on micrometer screw gauge and vernier caliper, hopefully, because like the majority of the questions are like for the previous papers that you had are from mainly the micrometer screw gauge and vernier caliper, right? So this is traveling microscope. I'll be covering it after the micrometer screw gauge, right? So this one, line circle scale method, right? Line circle scale method, or like in this method, like there are like two scales mainly. One is one of the circular scales, the other one is a linear scale, and these two are working together to get the measurements, right? So I'm going to tell you the basics, right? Try to understand how the basics work. This is how the founder saw this. Right. So this is how the founder saw this. Who is the founder of this micrometer screw gauge? Is one of the early scientists in 15th century, right? Like many years back. Who's the scientist? William Gascoigne was the guy, right? William Gascoigne was the guy. So he found this theory seeing a screw nail, right? He was seeing a screw nail and he saw this screw nail, how the screw nail works. How the screw nail works. So now this is a screw nail. Right. So this is a screw nail, right? Something like this. Right. And you have seen the grooves there, right? All the screw nails have grooves, right? And these grooves have a certain gap, and those gaps are equal in sizes when it's going down, right? So this groove, we call it as a pitch. Like hear it correctly? Pitch. The word is pitch, right? Yes. P-I-T-C-H, pitch. So the pitch have a certain size, which is how many millimeters? 0.5 usually, right? Now this pitch is usually 0.5 millimeters in size, right? And in a screw nail, when you rotate it, right? When you rotate it, it moves in a linear direction, right? When you rotate it, the linear movement is also there. It's going down. When you rotate it, the screw nail goes down. That's how it works, right? So there is a circular motion and a linear motion. So the Gascoigne was thinking, like, when you rotate one rotation, one circle, the linear scale or the shaft of the nail will move a certain distance, which is usually 0.5 millimeters. And he was thinking, how do I use this for measuring the lower values, like 0.1 millimeter, maybe lower than that, 0.01 millimeter. How do I use this to measure like very low values? He was thinking, right? So now this is the only thing he saw. What? Circulating this for one rotation, you get a 0.5 millimeter of a distance. So now I'm asking, if you want to measure 0.1 millimeter using this, right? Or if you are to travel a 0.1 millimeter in the linear direction, what would you do? How do you measure a 0.1 millimeter either of a movement in the linear scale, or how do you measure 0.1 millimeter of a value using this? One rotation is 0.5 millimeters itself. I want you to measure 0.1 millimeters. How do you measure it? Bo, big brain. Still. Yes. Not big brain. What is big then? Tell something. Tell. Have to have a big brain. Like almost all the shorts guys were here were like brilliant in the past. Huh? You tell. That's fine. Tell. Yeah. You have to rescue the respect of the short people here, because almost all the short people were like brilliant in the past days, like the past years. They were brilliant. Yes. Even the Einstein is short. Yeah, he's short. Yeah.
I have a small problem. So, like, Virgin Canopy, it was named after the scientist.
Yeah.
Why couldn't he name this one? Like,
It's his like if he's wanting to do it, only he would put the name. That's all. Okay. Right. Now this is what like the Gascoigne saw. He saw that when you rotate a screw nail for a one rotation, for a one circle, it will start moving 0.5 millimeter of a value in a linear direction downwards. And he was thinking to measure 0.1 millimeter of a value using this. He went further. He went further than 0.1 millimeter. Like I'm asking you now, how, if you got the screw nail, how would you show a 0.1 millimeter value using the rotation and the linear movement in the screw nail? How would you explain it? How would you show like a 0.1 millimeter of a value? Even the online people, if you know something, just text in the inbox, I can see it. Tell something. How do you measure 0.1 millimeter? It's easy. Huh? Poddak karakona. That's a good answer. Poddak karakona. How much should you poddak karakona? Kochara?
0.5 divided by 5 is 0.1.
Yes. Exactly. So chuttak means in the sense of how much. You have to tell it. You can tell it in exact value.
Like if you rotate karna one time,
Hmm.
so 0.5 karna.
Yeah.
एक mark करने
No, you're there. Now, you said like 1/5 of the value should be there of 0.5. So, if you rotate the complete circle one rotation, that is 0.5. So, 0.1 is 1/5 of that. So, how much should you rotate the circle? 1/5, isn't it? Isn't it? You should rotate the circle 1/5 of a division, right? You just draw it. Yeah. You just divide the circle into 5 divisions. 1, 2, 3, 4, 5. Simple. Isn't it? You divide it into 5. Now what do? Now you rotate only one division. Like there are 5 divisions, right? You only rotate one division and you get a 0.1 millimeter of a linear movement, isn't it? Now if I take this into a table, it will be something like this, right? It will be something like this. So there are 2 scales, right? One is circular and the other one is linear. And if it is one rotation, right? If it is one rotation, the linear movement is a value of a pitch, which is usually 0.5 millimeters, right? And now you're gonna rotate how much? 1/5 of the complete rotation, right? 1/5 of the complete rotation, which is 1/5 of the whole rotation, right? And how much would the linear scale move? 1/5, right? It is also 1/5 of a movement should show. So මෙයාගේ rotation එකෙන් ඔයා 1/5 ගත්තොත් this will also move only 1/5, which is 1/5 of 0.5 millimeters. How much? 0.1 millimeter, isn't it? So if you rotate 2 divisions, what happens? 0.2. If you rotate 3 divisions, 0.3. 4 divisions, likewise. So this is how he saw it, right? And he was thinking of making an instrument. Simple thing he was doing is something like this. You're gonna stuck the screw nail. You're gonna stuck the screw nail in between 2 of the, let's say this is just a typical diagram, not the proper one. This is a typical diagram. So this is, we hope that how he made it, right? Right. He's gonna stuck the, let's say the screw nail right in between like 2 of the, let's say these are wood strips, 2 of the wood strips, right? He's gonna stuck the screw nail in between 2 of the wood strips. And he's going to place one of the let's say, a object, some sort of object in between, you know, somewhere here. I'll take a different color for that. Let's take this one, right? Not that one. I'll take this one. Right. So it's going to place something like this here, right? Kind of this kind of object, and the screw nail will directly come to here, right? Right. So the screw nail is now here, right? So initially it was in the bottom of the, you know, the wood strip, and you'll have to take it up, rotating back to have the, you know, the height of the object we have placed here, isn't it? Right? So you have to take it back. Like, let's say it took back 3 rotations and 4 divisions, right? It took back 4 rotations and 3 divisions to get the height of the object I have placed here. So can you tell by the number of rotations and the number of divisions he took rotating back the height of the object? Can you tell? Can you tell the height of the object by the number of rotations and divisions he took the turns back? Can, right? So how many rotations? 3 rotations were there. And how many divisions? 4 divisions were there. So 3 rotations mean, what is the height? So 1 rotation was 0.5 millimeters. 1 rotation was 0.5 millimeters, which is the, say the word. 1 rotation equals to 0.5. We named it, yes, pitch, right? We named it pitch. And 3 divisions, no, 4 divisions. So 1 rotation is 0.5. So 3 rotations mean 1.5 millimeters. And 4 divisions. How much is that? 4 divisions mean 1 division is 0.1, isn't it? 0.1. And 4 divisions mean 0.4. So how much would be the total length? That is 3 rotations plus 4 divisions, isn't it? This would be the simple formula. Rotations 3, divisions 4. So rotations 3 කියලා කියන්නේ 0.5 ඒවා 3. plus divisions 3 කියලා කියන්නේ 0.1 ඒවා 4. නේ 4. 4 divisions. I took 4 divisions. Right? ඒ කියන්නේ complete rotation 3යි divisions 4යි. අර චුට්ටි කෑලි 4යි. මෙන්න මේ කෑලි 4යි. Right? So the complete length will be how much? 1.5 millimeter plus how much? 0.4 millimeter, which is altogether 1.9 millimeter of a length, isn't it? Simply that way you can calculate it. Now this is a typical, you know, the explanation. Now this is not the proper one. So the proper one, the Gascoigne went further and he divided the circular scale into 50 divisions. මෙයා circular scale එක කඩනවා කීයකටද? 50 divisions වලට. හරි. Then how much would be a division value of it then? Division value එක කීයක් වෙයිද? දැන් මේක කීයද? This is 0.5 divided into 5 divisions. Right? 0.5 divided into 5 divisions, isn't it? So if we divided it into 50 divisions, how much would be a 1 division of the circular scale in linear values? එයා 50කට divide කරලා එකක් කරකියුවොත් එක linear value එකක් කීයක් වෙනවද? Guys tell. Huh? කීයද? 0.50කට කඩන්න. circular scale එක 50කට කඩනවා. yes. එතකොට 0.5 ඒවා 50කට කැඩෙනවා. එතකොට කීයද? 0.01. That is 1/100th of the millimeter value, right? 1/100th of a millimeter value. කියන්නේ ගොඩාක් small, හොඳයි. 0.01 කියලා කියන්නේ ගොඩාක් පොඩි. Do you get it? Like 1/100th of the millimeter value. Millimeter එකෙන් 100ක් කඩලා තියෙයි. චූටි value එකක්, right? That is the there. ඇයි කරන්නේ යාර? What why the hell is we discussed that's the thing, we discussed this. What is the listen, so what is the need of this? We discussed about the error, right? Error equals least count over measurement. Now study those. The error equals least count over measurement. What happens when the least count have lower values? Yeah, the error decreases, which means the accuracy increases. So if you want to have a better accuracy when you are taking the measurements, you will have to have a lower least count. But that only depends on the measurement that you take. Measurement එක ලොකු වෙනකොට error එක මොකද වෙන්නේ? What happens when the measurement increases? The error decreases, isn't it? Because the error equals what? I'm going to write it here and erase it. Now the error equals what? Error equals least count over measurement, right? This is the error. So when you are having a lower least count, that means if the least count is very low, the error will also be low, which means the accuracy is high. Error low means accuracy is high. And what about the measurement? If you increase the measurement, the error will be, would it? It's a division. What happens when you divide in a larger numbers? The whole thing decreases. Short, listen. What happens when you increase the measurement? The whole thing, like if you increase this value, the whole thing will decrease. So that means, now you tell, error also decreasing. මේ measurement එක වැඩි කරොතින් මේ සම්පූර්ණ division එක ගන්න තියෙන්නේ. ඒතකොට division එක අඩු වෙනවා. ඒ කියන්නේ error එක අඩු වෙනවා. That means the accuracy වැඩි වෙනවා, right? So that means greater the measurement size, the higher the measurement size, the accuracy will be high, isn't it? So for higher measurements, accuracy වැඩි. Higher measurement can accuracy වැඩි. So for a higher measurement, would you need a lower least count? No, because measurement එක වැඩි නම් එතරම් accuracy එක වැඩි. ඒ හින්දා ඒව තවත් ගොඩාක් අඩු least count වලින් measure කරන්න ඕනේ නෑ. දවා කිලෝමීටර් එකක් මයින්නවා. 0.01 මිලිමීටර් වලට මයින්නවද? accuracy එක. එහෙම වෙනවා පිස්සු ඇති. නේ? මයින්නකොට 0.01 accuracy එකකින් කිලෝමීටර් විතර මැන්නොත් එතකොට large values මයින්නකොට ඔයාට least count එක ගොඩාක් පොඩි කරන්න ඕනේ නෑ. But what happens when you are to measure like very low values, like 1 millimeter, 2 millimeter, 3 millimeter sort of values, when you're measuring those things? If the least count wasn't enough, you'll be getting like inaccurate values, wouldn't you? නේ? Inaccurate values එනවා එතකොට. least count එක ගොඩාක් අඩු නැත්තම් ඒ වගේ එකකදී ඔයා 1 mm, 2 mm, 3 mm measure කරනකොට ඔයාගේ accuracy එක අඩු වෙනවා. Isn't it? So when you are measuring like very small values, you will have to have a very low least count, isn't it? That's the thing. That is the reason. When you are measuring very low values, you have to have a very low least count. Otherwise, you will get it inaccurate. Get it? So it's in the equation. I taught you the equation. Study, yeah. මේ ටික මතක තියෙන්න ඕන. මේ ටික ඔක්කොම link වෙනවා. Right? So when you're studying, like try to connect all the theories together, because at the end you'll have to have a collective knowledge of everything. මොකක් හරි එකක් ස්ටඩි කරනකොට when you study something මේක මෙතනටත් link වෙනවා. මෙතනටත් link වෙනවා. ඒ විදිහට ඔයාලට කියන්න පුළුවන් වෙන ගානට මේක ස්ටඩි කරන්න. that is the best level. දැන් අපි ඉස්සරහට පාඩම් කරන්නේ ආපහු මේකේ තියෙන ඒවාත් එක්ක කනෙක්ට් වෙනවා. ෆිසික්ස් වල කතා කරන ඒවා සමහරවිට මේකේ තියෙන ඒවාත් එක්ක කනෙක්ට් වෙනවා. අන්න එතකොට මේ මෙමරි රිකෝල් කරන්න පුළුවන් නම් අන්න that's the best level of study. Right? Can do that. Hari. Right. So you understood this one, right? When you have like a circular rotation of 1, it will move in the linear direction for 0.5 millimeter of a distance or a value. And if you divide the circle into 5 divisions and rotate only one division, the linear scale will only move 0.1 millimeter, which is this. But the Gascoigne, the original founder, went further and he divided the circular scale into 50 divisions. Right? He divided it into 50 divisions. So how much would the one division of 50 divisions of circular scale moved when like how make it linear scale එක කොච්චරක් යයිද 50 divisions වලින් 1 divisions rotate කරොත් කොච්චරක් යයිද 0.5 යනවා full rotation එකකදී 50 වලට කඩලා 50 වලින් එකක් බැලුවොත් අච්චරට මෙච්චර නම් එක division එකකට කොච්චරද හරි 50කට 0.5 නම් එක division එකකට කොච්චරද කීයක් යනවද ඒකට 0.01 millimeter of a value, which is very low, right? Which is very low. මේක තමයි Gascoigne ගේ finding එක. එයා ඒකට හැදුව වෙනම instrument එකක්. I'm going to show you the instrument now. Right. Give me a second now. Right. So this is the instrument. Right. Now this is the instrument. Listen, guys. Can you hear the sound? You know the original instrument is also having the same, maybe a bit different, but having the almost the same sound. Huh?
What is the size?
I wouldn't tell that. Why would I tell that? Yes, there. Right. Anyone can steal it. Anyone can steal it. Like we are the first, right? We are the first people to use the simulations in the tuition history. As far as I know, none of the people have used the simulations to teaching. So we are the first to do that.
Will you keep it private?
We don't have to. Anyone can use it. Like knowledge has to spread. We don't have to like keep it as secrets. That's fine. Huh? No, it's not confidential. It's really open to anyone to steal. That's fine. Not to steal, just. Yeah. Yeah, you know, like knowledge can be shared. Either knowledge can be shared, or like it'll be stealing if someone takes it without acknowledging the other person. Usually that's how it happens, right? So if someone is acknowledging that I'm taking this from you, that's a a ethical way of doing it. But majority of the people, they do it secretly, so it's stealing. Sort of, isn't it? Yeah. So I'm telling, I'll be sharing it, or I'll be open to give it. I'm not hiding anything. The websites are there, so they can take it. Yes. Huh? What? Yeah. Yeah, it's there. So yeah, it's open. Make a bet. This is not really 3D. Rotate කරන්න බෑ. Rotate කරන්න පුළුවන් ඒවා හදන්න පුළුවන්. There's a software called Blender. Using Blender, you can create like 3D. We've been trying to make some 3D objects. In the future, I'll be showing you everything. So now this is one of the pre-prepared ones, like simulations, not prepared by myself. It's there in the websites, right? So this is what? Micrometer screw gauge. And Using this micrometer screw gauge, you can measure the the size of an object, which can be very small, like 1.5 millimeters, 2 millimeters, likewise. And because of that, like we are measuring only like very small values using this. Because of that, the highest value can be measured is very low, as now these are like millimeter values, 5, 10. It is only like 11, right? So the linear scale you can measure only 11 millimeters. So 11 millimeters is like how much? Like 1 centimeter of a value almost, right? So making measure ගන්න පුළුවන් maximum කොච්චරද? 1 centimeter. So 1 centimeter මයින්න measurement instrument එකක් ඕන. ඕන. That's why they have created it, right? ඒ කියන්නේ මේකෙන් අපි මයින්නේ පොඩි values විතරයි. Because we have a very low least count. With that very low least count, we'll only have to measure like small values. If we are measuring larger values, we don't have to have this much of a least count. Get it? ඒ හින්දා මේකේ 0.01 millimeter of a least count තියෙන හින්දා 1 millimeter, sorry 10 millimeter වගේ තමයි maximum mine. ඊට වඩා mine නෑ. Right? You have to මේකත් මතක තියාගන්න ඕන. Vernier එකේ සාමාන්‍යයෙන් 10 to 15 centimeters වගේ මනින්න පුළුවන්. Vernier එකේ 10 to 15 centimeters වගේ මනින්න පුළුවන්. මේකේ මනින්න පුළුවන් කොච්චරක් වගේද? 10 12 millimeters වගේ මනින්න පුළුවන්. හරි. 10 to 12 millimeters වගේ තමයි මේකේ මනින්න. ඒතර ලොකු difference එකක් තියෙනවා. හරිද? ඒකට හේතු තියෙනවා. We will be discussing it in the future and I'll be giving questions regarding those as well. So like keep it in mind නා. මම ඔය ටිකක් අඹරලා කර වෙන්න ටිකක් දෙනවා ඈ. ඒකින්ද like remember all those things that I am telling you. They will always be important even in your life. When you are like working somewhere, it will be important, right? So this is the instrument. Now this is how it works. So there are two scales, right? Now this one is the circular scale, which the circular scale has divided into 50 divisions. If you're seeing it, now this has a 0 error. Went somewhere else. Come here. Right. Get over here. Right? Scorpion. Right. So this is the circular scale. Right. And circular scale have how many divisions do you see? How many divisions are there? You see 45 here. 46, 47, 48, 49. 50. So circular scale have 50 divisions there, right? And we discussed that when the circular scale is rotating for a one rotation, and there will be a linear movement of the shaft or the pitch in the linear direction. Likewise, same thing happens. Listen, when I rotate this for a complete one rotation, බලන්න හොඳේ 5 10 15 20 25 30 35 40 45 and it's 50. You see it? 50. So when I turn it 50, now this part we call it spindle. This shaft we call it spindle. It also came back. You see that? So it came we discussed that if I rotate one rotation, the moment of linear shaft will be 0.5 millimeter. So I rotated this for one rotation. So this has moved how much? 0.5 millimeter of a value, right? So now the gap here is 0.5 millimeter, isn't it? The gap here is 0.5 millimeter, right? So I'm going to rotate another one. Now that 0.5 millimeter of value is labeled here in the linear scale. Now there's a linear scale here, you don't see it, you only see the 0 here, right? I'm going to rotate it more, you'll start to see the lines. Do you see the line? That line was already there, but අර මෙන්න මේ circular scale එකට වැහිලා තිබ්බේ හොඳේ. මේකට වැහිලා තිබ්බේ. හරි. දැන් බලන්න මම පොඩ්ඩක් තව ටිකක් එහාට යවනකොට it appears right ඒ කියන්නේ මේ තියෙන ලයින් එකෙන් එයා දීලා තියෙන කොච්චරක වැලියු එකක්ද 0.5 mm වැලියු එකක් right ඔයා මේ circular scale එක complete එක rotation එකක් කරකෙව්වහම පස්සේ ඔයාට එන්නේ හරි මෙන්න මෙතනදී හරියටම 1 mm of a, sorry 0.5 mm of a distance ඒක ලේබල් කරලා තියෙන්නේ මෙන්න මේකේ හරි එහෙනම් මෙයා කීයද මෙයා 0.5 මෙයා 1 mm තව එකක් rotate කරාම 1.5 mm තව එකක් rotate කරාම 2 mm 2.5 mm ආපහු 3 mm likewise the linear scale is appearing නේ ඔයා circular scale එක කරකවනකොට linear scale එක appear වෙනවා ඒ linear scale එකෙන් පෙන්නන්නේ linearly 0.5 values වලින් කොච්චර distance එකක් මෙයා ඉස්සරහට එනවාද කියන එක නේ do you get it so that is one thing හරි දැන් මට කියන්න දැන් මෙයා කොච්චරක් move වෙලාද 1 අපි 0.5 values පල්ලෙහානේ 0 0.5 1 1.5 2 2.5 3 නේ ඒතර උඩින් calculate කරන්න ලේසි 1 2 3 3 millimeters have moved right 3 millimeters have moved and apart from that 3 millimeters some of the circular scale divisions also have moved like how many circular scale like දැන් මේකේ 1 2 3 වෙනකොට හරියටම 0 එකෙන් ඉවර වෙන්නේ සම්පූර්ණ rotation එකක් ආවම පස්සේනේ මෙතන 3 වලින් ඉවර වෙන්න ඕන හරියටම ඉවර වෙන්න ඕන හැබැයි ඒ rotation එක පහු කරලා divisions ගානක් මෙයා ඉස්සරහට ගිහිලා can you see it there's a number of divisions it has moved forward like how many circular scale divisions have rotated further now the 0 is here right it has like aligned with the which circular scale value 5 6 7 so that means apart from this 3 millimeter value it has moved a bit further how many divisions 7 divisions so we know already one division is how much 0.01 so 5 divisions mean how much has it moved 0.05 has moved isn't it so then apart from 3 millimeters of value here it has moved 0.05 millimeter of a value then altogether how much has it moved 3 millimeter plus 0.05 millimeter sorry yeah 7 yeah 3 millimeter plus 0.07 it's 7 right so how do you calculate it you have to have two the scales one is the linear scale which is this part නේ ඒකේ 0.5 values වලින් තමයි calculate කරන්නේ ඊට පස්සේ අපි පාවිච්චි කරන මොකද්ද circular scale එක ඒකෙන් 0.01 values වලින් තමයි calculate කරන්නේ නේ දැන් මේ දීලා තියෙන එකේ බලන්න මේකේ බලන්න now this one right now tell me how many linear scale divisions are there tell how many linear scale divisions are there how many do you see 3 right 3 linear scale divisions are there that means now මේ උඩින් 3යි that means how many millimeters have it moved 3 millimeters right millimeters 3ක් move වෙලා right ඊට පස්සේ 3 millimeters වලින් පස්සේ how many divisions in the circular scale has it moved බලන්න මෙන්න මෙයා කෙලින් බලන්න මේ midline එක කෙලින් බලන්න 25 divisions have moved so we know one division is 0.01 ඒ වගේ කීයක් move වෙලාද 0 ඒ වගේ 25 divisions move වෙලා ඒතකොට 0.01 into 25 divisions තමයි ඉස්සරහට move වෙලා තියෙන්නේ ඒකෙන් මම length එක calculate කරොත් how do you calculate the length so it has to have two scales when you are measuring the length හරිද now this is when you are measuring the length හරිද දැන් ඔයා length එක කියලා measure කරන්නේ මෙන්න මේ මෙයා ඉස්සරහට ගියපු length එක හරි මේ ඉස්සරහට ගියපු length එක it should be taken using two of the scales. One is the linear scale here. Now this is one of the linear scales, or we call it main scale, right? This is linear scale, and using the circular scale. This one is what? This one is circular scale. You have to take the measurement using these two scales, right? So now tell me the linear scale value here. Here. 1, 2, 3. It is 3 millimeters, right? මම මේක ලියන්න එතකොට length should be taken using the linear scale. Plus circular scale, right? Now the linear scale value here is how much? 3 millimeters plus circular scale value is 25 divisions, and we know one division is 0.01 and it has moved 25 times. එහෙනම් circle එකේ අපිට එන්න ඕන 0.01 millimeter times how much? 25. So how much is the complete length? 3.25 millimeter. Get it? Now 3.25 millimeter is the length it has moved, the complete length. So we have measured 0.01 millimeter of we have measured like a value with the accuracy of 0.01 millimeter of a least count. නේ බලන්න points දෙකකට ගත්තා 3.25. එතකොට මේ 3.25 කියන gap එක තියෙන්නේ කොහෙද? It is here. Now how do you measure length of object like that? මේ විදිහට තමයි length එක එන්නේ. Now we want to measure object with the accuracy of these මේ 2 decimals using this instrument. How do you going to do it? මෙතනට මොකද කරන්නේ? object එක තියෙනවා. That's it. Right? මොකද කරන්නේ? මෙතනට object එක තිබ්බා measure කරා. ඒ කියන්නේ ඔයා මෙන්න මේ circular part එක කරකවලා spindle එක පිටිපස්සට අරගෙන මෙතනින් place කරනවා මොකද්ද? object එක. object එක ඔයා මෙතන place කරලා මෙන්න මේ තියෙන main scale එකයි circular scale එකයි පාවිච්චි කරලා අර කලින් විදියට value එක calculate කරා නම් එතකොට එන්නේ මොකද්ද? මෙතන තියෙන complete length එක. එසේයි. So අපි මෙතන ගත්ත කීයද? 3.25 නේ. අපි බලමු if the value is correct. Correct, right? 3.25. Get it? Right. So that is how you do it. Right? Shall we come to the theory now? Come to the theory note. Did you understand the whole thing? Hi, අපි ඊට පස්සේ measurements ගමු. Huh? Yeah, fine, sure. Yeah. Right? Did you all understood how the theory works? Sure? Bro, you understood? Yes. Isugo already knows. Understood it? For sure? How it works? Bro, huh? See the lady? Then shift to this side. Huh? Oh, we are a JC. Right, guys online. Shiny, Sairu, Asit, and there's Nayuga, Yash, I don't know. Is it clear? All good, nice. Right, so that is how it works, right? That is how the instrument works. Like me, think of a bit, you will understand, right? Use your brain cells, otherwise, neither. We can keep like very thin objects, like a metal sheet, very thin metal sheet, something like that. And to measure diameter of a very small spear. Likewise, very small things were measured using this instrument, not the big ones. Very small things are measured using this. Get it? And let's say the diameter of a wire, a copper wire, it will be very small, no? So you can measure it using this one. Get it? Because for the calculations, for the the practical things, are diameters වගේ ඕන වෙනවා. So when you are calculating in the physics, අර diameter එක measure කරනවා නම් practically you will have to use this one. Right? Right. So come to the paper. Come to the tute. Right. Linear scale method, right? Come to this one. Listen, nah? So the linear circular scale system is a system constructed to allow so small measurements of length to be made using a circular scale around or outside of a linear scale. Now this instrument, yes, that's what I said like the earlier. I'm gonna skip it because these two instruments are related together, right? So listen, shh, come to the tute. Go, tute take go. Right? Where's the tute? Come to this page, right? Listen, in both instruments, the circular scale part is designed to move along the linear scale as it is rotated, right? Right? එතකොට මේකේ මොකද්ද වෙන්නේ? circular scale එක අපි rotate කරනකොට අර shaft එක ඉස්සරහට move වෙනවා. When the circular scale rotates one round, the distance it travels along the linear scale is called what? When you rotate one rotation, the distance traveled by the linear scale is called what? Write it. Pitch. Write down. Pitch. Huh? Not B, P. P-I-T-C-H. Pitch.
During the exam, we should use the scientific calculator or no?
The scientific one. Right? Pitch. The circle scale is marked along the circumference of the rotating part. Right? So, there is a rotating part and the circular scale is labeled there. Now, no speaking when I am teaching. Huh? Yeah. You are like me, married couple in the bed. Oh.
Didn't expect that.
Yeah. Like, don't whisper to the other person's ear. Like, nee, they will feel bad when you do that. Nee? Yes. Right. Listen. Right. If the circular scale is divided into x number of divisions, the number of circular scale divisions that pass the main scale when the circular scale is rotated one round is equal to x. If it is divided to x part, which means like 50 divisions. So සම්පූර්ණ rotation එකක් කියන්නේ divisions x ගානක් ඉස්සරහට යනවා කියන්නේ. Right? Accordingly, the distance traveled along the linear scale in the rotational displacement of one part of the circular scale is equal to. ඒ කියන්නේ අපි එක division එකක් කරකෙවුවා ඉතින්. දැන් කොච්චරක් යනවද ඉස්සරහට? එක division එකක් කරකෙවුවාන් පස්සේ ඉස්සරහට යන value එක කීයද? Tell it in like algebraic forms. Now the number of divisions are x. Right? එතකොට අපි දන්නවා complete rotation එකේ කියන්නේ pitch එකක්. Pitch එකයි number of divisions we පාවිච්චි කරලා කියන්න බලන්න එක division එකක් කරකෙවුවාන් පස්සේ ඉස්සරහට යන කොච්චරද? Pitch over x. Right? Or the pitch over number of circular scale divisions. Right? And මෙතනට එන්න මොකද? Equals to pitch over x, and x is circular scale division. CSD කියලා කියන්නේ circular scale divisions. Right? Pitch කියලා කියන්නේ circular scale divisions. CSD. So that will be also the least count, isn't it? That will also be the least count, because if you divide 0.5 by 50 divisions, it will be 0.01. So 0.01 is the lowest value it can measure. So if you are asked to find the least count, it will also be the same. It will be pitch over circular scale divisions, right? Pitch එක circular scale division ගානින් බෙදුවා නම් වාට එන්නේ මොකද්ද? least count, right? So listen. Therefore, the distance traveled by the circular scale along the linear scale is the smallest measurable magnitude equal to pitch over number of circular scale divisions. ඒක highlight කර. Right? Distance traveled by the circular scale along the linear scale is the smallest measurable magnitude equal to pitch over x. Pitch over x is CSD, right? X කියන්නේ CSD කියන එකත් ලියන්න එතන. Now x is CSD. CS circular scale division. CSD is circular scale divisions. CSD. So if you want to find the least count, how do you find it? You divide the pitch by the circular scale divisions. Wrote it down? You what? Good. මෙතනත් මේකත් CSD කියලා because it's also x is circular scale divisions, right? Right. Yeah, sometimes I can't tell though. Depends. Depends on the head you have. Maybe a sensitive head. Right, listen. Therefore, the least count of circular linear scale instrument can be shown as. So, what will be the least count now? Yeah, how do you measure it? Like the equation would be? Yes. Over? No, don't say x. CSD, right? Pitch over circular scale divisions. So, write it down. Yeah, don't use the bad words, right? LC equals not x, what? It's okay to write CSD, that's enough. CSD ලියුණා නම් ඇති, right? But you'll have to remember what CSD is. Circular scale divisions. CSD. CSD. X නෙවෙයි, X එපා. Pitch over X like it sounds bad. It sounds bad. Bro, it's coming ahead. Don't worry. You're still in the measurement. Like, try to get this thing. We are doing it in 2026 now. We already did it. Yeah. Newton. Bro. Yeah, I'll have to show you all the recordings back. Huh? You're Indian, eh? Your website. We finished it, and then it is to be started in 2026 today. Yes. So come to the class 3 to 5. 3 to 5 today. Be there so you can learn. Right? Got this? So this is the least count. Right? Listen. Pitch of a certain instrument is 1 millimeter, and there are 100 divisions in the circular scale. Least count would be. Write down the equation first and then do the calculation. Always write the equation, right? Always remember to write the equation. How much? How much? Now the least count. So the equation is least count equals pitch over CSD. Don't say x. Not gonna work. CSD. Now the x is CSD. And the pitch equals how much? 1 millimeter. And the CSD is 100. So the final answer will be 0.01 millimeter. Got it? Easy, right? And come to the second one. Do this one. Now you have to remember. So now the pitch is the gap of a groove. Remember? Good. Pitch is the gap of a groove, isn't it? Of a screw nail. Or a screw nail like a
Distance between the
two grooves, not the two grooves, of one groove. The gap of a one groove is pitch in the screw nail. Yeah, can tell threads. Threads can apply threads some. Yeah, tell. මේවා theoretically තේරුම් ගන්න ඕනද? You'll have to understand it, otherwise no point. Because science is all about understanding, like storming your brain. Thinking, yes.
It will take some time, right? To take all the way.
That's fine. That's fine, but still you'll have to give a bit of a stress to the brain to understand. Right? Listen. So, so the least count here is pitch over circular scale divisions. Right? මේක මුලදී අමාරුයි. හැබැයි පස්සේ යනකොට ඔක ඩිසෝල්ව් වෙනවා. හැබැයි මුලදී අර you will have to focus. එතකොට තමයි මේක ලේසි. නැත්නම් අර මුල් හරිය මිස් වුණාන් පස්සේ අග හරිය යනකොට මොකද? අර මිස් වෙච්ච ඒවෙන් රැක් පයින්. That happens, right? So listen carefully. So the pitch is half, which is 0.5 millimeters, and the divisions are 50. So the answer will be again 0.01 millimeter, right? Right. So now this is a right. So this is like a simple explanation how the history worked and how many who found it and sort of thing, right? So it's not very important. Go through it, read it. Now come to the instrument. ලේසි නම මොකටද? මොනවද? නෑ ඒව අහන්නේ. ඒව නිකන් අර knowledge එකට දාලා තියෙන්නේ. Right, listen. So you have to know all the parts of a micrometer screw gauge, right? මේ තියෙන micrometer screw gauge කියන instrument එක. We already saw it. Now tell me what are the parts here? Now this one is anvil. This one is called anvil. Anvil. This one is called spindle. Who's the ninja? Yeah. Put it silent now. Silent. Not gonna happen again. Not gonna happen again. That's the last time. Is your auntie a ninja? I don't know. That sounds like a ninja. Right. So this is a spindle, and this is the anvil. And the anvil doesn't move. The spindle moves. Right. Spindle moves. Spindle moves, and when the spindle moves, the scale here appears. What is this scale? It's either the linear scale, and we can call it main scale as well. So fine, it's if we write it main scale, that's fine, main scale. Because there was a main scale in vernier as well. So they use it main scale. So it's easy to remember, main scale. Right? And this one is what? This one is circular scale, right? This one is circular scale. Bro, don't shout. right? This one is thimble. And this is called ratchet. It's called ratchet. And this one is frame, you know. This is frame. Right. Fine? Yes. So anvil is there, spindle is there, main scale there, circular scale, thimble, ratchet, and the frame. Right? So how are you gonna measure something? What do? You rotate the thimble, right? Usually we rotate the thimble. You rotate the thimble, then you take back the spindle, and you place the object there, and again you're going to rotate it back till the spindle and the anvil stucks between the object, and when it got stuck, you take the reading from the main scale and the circular scale. But now there's a speciality in this instrument, right? There's a speciality in this instrument. What is the speciality? If you are to measure a thin, let's say a metal strip, very thin metal strip like a copper metal strip, right? And if you measured it using a vernier caliper, using its jaws, what would happen to the copper thin paper?
It will get squashed.
Yes, like you can't measure like a very thin copper plate using a vernier caliper. What happens? The jaws will damage the thin paper, wouldn't it? Because it will pressure on it, right? It will pressure on it. So, but when you are using a micrometer screw gauge, there is a method called the ratchet method, right? Ratchet method. That is why the ratchet is there, because the ratchet is also there to rotate. But usually we use the thimble to rotate. But when the spindle comes closer to the object, we are not using the thimble anymore. මෙන්න මේ thimble එක object එක ළඟට ආවම පස්සේ අපි එතනින් එහාට thimble එක use කරන්නේ. What do we use? We use the ratchet. ඊට පස්සේ ratchet එකෙන් තමයි rotate කරන්න ළඟටම ගියාම. When the object got stuck and when it is ready to measure, the ratchet will stop, like moving forward the spindle. It will rotate alone without moving the spindle forward.
So it's a locking system.
It's a locking system, sort of, right? So the ratchet will start moving alone, and when it starts moving alone, what happens? There will be sound. What is the sound? Click sound. The click sound will be there, like in a wine watch, right? It will give a click sound, right? මම ඒක අර මේ එකේ තියෙනවා. Simulation එකේ තියෙනවා. මම ඒක පෙන්නන්නම්, and I will show you the original instruments. ඒකෙත් බලා ගන්න පුළුවන් ඒ click sound එක. හරි. click sound එකක් එනවා. Right. So when the click sound appears, there will be lock here. මේකේ lock එකක් නැහැ. හරිද? සමහර instrument වල නැහැ. හැබැයි usually there is a lock here. මෙන්න මෙහෙම එකක් තියෙනවා lock එක. අපි ඒක ඇඳලා label කරගමු. හරි. මේක lock එක. හරි. When the click sound appears, what you do is you put the lock down and take the measurements. There are like winding watches. No? And ඒ වගේ ඔය click sound එකේ තියෙන. කරස් ගාලා sound එකේ. Winding watches. Right.
Also, like to make the physics part easy, you should understand what's really going on.
Yes. That is
Not
what.
just study.
Yeah.
Then only the theory gets wrong.
Of course. No, that's the thing. You'll have to understand it. Like you'll have to put some brain on it. Otherwise,
That's why most of students don't get it.
yeah, that is the main reason. Because you'll have to get like give some stress on your brain. අර මේක මොකද්ද මේ කියලා පොඩ්ඩක් හිතන්න. Likewise. You have to think. එහෙම හිතුවන් පස්සේ තමයි මේ brain එක වැඩ ගන්න ගන්නේ. නේ? So how do you use your brain? No, not like that. How do you use your brain? When you have either theory note or a question, you read it and you sometimes might not understand, right? So you have to think what මොකද්ද මේ නේ and that's when your brain starts to understand. That is when the learning starts, right? එහෙනම් පොඩ්ඩක් පොඩි ස්ට්‍රෙස් එකක් හැමතිස්සෙම දෙන්න ඕන brain එකට to make it understand. Otherwise අර නිකන් ඔහේ කියවගෙන ගියාට හරි just අහගෙන ඉඳියට හරි ඔක හරියන්නේ නැහැ. You have to put some brain on it. Otherwise no learning. නේ that happens, right? Come to this one. So the part of micrometer screw gauge is shown above in the figure. The anvil is stationary in the side of the instrument. Anvil like a stationary thing, doesn't move. In the other side of the frame, spindle is located facing the anvil. Along with the spindle, the thimble and the thimble head can be seen, and by rotating the thimble, spindle can be moved back and forth, right? අර thimble එක කරකවල තමයි අපි spindle එක ඉස්සරහට පස්සට යවන්නේ, and the anvil is stationary, it doesn't move. Right, in a micrometer screw gauge with no zero error, when the spindle and anvil are touched, the zero in the circular scale and the linear scale should be overlapped. Anvil එකයි spindle එකයි touch වෙලා තියෙනකොට, that is the origin, like the initiation, like the starting of the instrument. And when the anvil and spindle are touched together, the zero of the main scale and the circular scale should be aligned. අර vernier කීම වගේ තමයි. anvil එකයි spindle එකයි touch වෙලා තියෙනවා කියලා කියන්නේ අනිවාර්යෙන් main scale 0 එකයි vernier scale 0 එකයි align වෙලා තියෙන්න ඕන. align වෙලා නැත්තම් what does it mean? If those two lines are not aligned, there is a zero error, right? Align වෙලා නැත්තම් that means there is a zero error, right? Right. To avoid high pressure between anvil and spindle, object kept in between, and then the object is tightened with the thimble. Because of the ratchet in the thimble, the spindle can be stopped moving before excess pressure is applied. एक highlight कर. Because of the ratchet in the thimble, the spindle can be stopped moving before excess pressure is applied. So that is one of the specialities of the the micrometer screw gauge.
And that click sound also.
Yeah, the click sound also appears. ඒතර ආට pressure එකක් නැතුව මෙෂර් කරන්න ඕන නම් ratchet එකකින් තමයි final movement එක ගන්න ඕන thimble එකෙන් නෙමෙයි. Right? Right. Right. If a sound can be heard, the sound is called click sound. Yeah. Thimble head කියන්න පුළුවන්. Ratchet, thimble head දෙකම එකයි. කියන්න පුළුවන්. Right? Right. If a sound can be heard when the thimble or ratchet rotates, the setup is ready to take readings. Right? අර sound එක ඇහෙනකොට තමයි අපිට reading එක ගන්න පුළුවන්. ඒ කියන්නේ click sound එක එනකොට අන්න that is the moment when you take the measurements, right? It is advisable to lock the reading using the locking screw before taking the readings to increase the accuracy. අර lock එකක් තියෙනවා කියලා මම කිව්වේ. ඒ lock එක දාලා තමයි auto measurement එක ගන්න තියෙන්නේ, right? Now come to the next topic, getting readings using micrometer screw gauge, right? අපි ඒකට measurements ගන්න ගමු. Right, so this is the instrument, right? So we are going to take the measurements, right? So I'm gonna place it, like I'm gonna place the instrument in a like measurement taking position, and you are going to do the calculation, right? So what happens here? Now this is the thimble, right? Now this part is the thimble. This one is the ratchet. When the when the spindle and the anvil are touched together, it doesn't move further, right? So when it doesn't move further, this sound is coming. This sound is called what? Click sound. It also happens when the object is also stuck, and when it is touched together, when it can't move further, again the ratchet will give the click sound, right? And ඒ වෙලාවට තමයි අපි මොනවා කරන්නේද? measurement එක ගන්න. හරි? right. So අපි මෙහෙම දැන් මේ තියෙන thimble එක කරකවලා අපි මෙතනට object එකක් හිර ගන්නවා. දැන් ඔන්න මම මෙතන ඔබ්ජෙක්ට් එක තියලා මෙයාගේ මෙෂර්මන්ට් එක ගන්න හදන්නේ. හරි. දැන් මේ තිම්බල් එක කරකවනවා. හරි. good start. හරි. දැන් මේකේ lock screw එක නැහැ. අපි lock screw එක දැම්මද? Now what do you have to do? You have to take the measurement. So before taking the measurement, there's an equation to write. Right. So what will be the equation? Shall we write the equation first and come to the tube? Right. Right. Come to this part. Now when you are taking the reading, the equation will be right, length equals, right, length equals what? Length එක දැන් අපි මයින් pitch එක අපි මැනලා ඉවරයි. pitch is there for the least count. දැන් අපි හදන්නේ length එක මයින්. එතකොට scale දෙකකින් මයින්. One is the main scale, the other one is the circular scale. So it should be main scale plus main scale value, right? Main scale value plus circular scale value. Circular scale value. And what is the circular scale value again? How do you take the circular scale value? There's a least count, which is the value of one division, and you multiply it by the number of divisions. නේ අපි හිතමු 9th division එක align වෙලා තිබ්බයි කියලා. නැත්නම් final level තිබ්බ 9 division එක කියලා. එතකොට 9 division කියන්නේ කොච්චරක් move වෙලාද? 0.01 times 9 move වෙලා forward නේ. එහෙනම් ඒ කියන්නේ least count එක times 9 has moved forward, right? That is what it says, right? So how do you take it? LC into what? Circular scale reading. LC into circular scale reading. Circular scale reading is the number of divisions that has aligned in the circular scale, right? LC into CSR. Now do you see something same like the vernier caliper? It's the same equation, right? Because the vernier caliper has main scale value and a vernier scale value. And the vernier scale value was least count into VSR, vernier scale reading. It's more like same, right? So මේ දෙන්නම එක වගේ, but there are two different scales. Vernier එකේ තිබ්බේ two linear scales. මේකේ තියෙන්නේ one circular and one linear scale, right? Right. මේක තමයි එතකොට equation එක. What is the equation? මේක ඕන short ලියන්න පුළුවන් මෙහෙම. හරිද? මේ විදිහට short ලියන්න පුළුවන් කොහොමද? Length equals length equal කියලා මෙහෙම ලියන්න පුළුවන්. Right? මෙහෙම ලියන්න පුළුවන්. Length equal MSV, main scale value, plus CSV, which is circular scale value, and the circular scale value is LC into circular scale reading, CSR. මේක ලිව්වත් ඇති. MSV plus CSV, and CSV is LC into CSR. Right? LC into CSR. Right? Understood this? Sure? Right. Then let's come to the simulation. Right. So I'm going to place an object. අන්න object එක place කරනවා. හරිද? එතනම දැන් stuck වුණා. It got stuck. I have to put the lock. Nothing happened. I have to put the lock and you have to measure the value. So how do you measure it now? You have to take two values. One is main scale value and main scale is in 0.5 divisions. Main scale එක 0.5 divisions වලින් තියෙන්නේ. ඊට පස්සේ circular scale එකේ ගන්න ඕන reading එක අරගෙනවා multiply කරනවා number of least count එක අරගෙන number of circular scale divisions වලින් multiply කරලා value එක ගන්න. Write down the formula. Now take a different paper. Rough paper එකක් ගන්න මොකක් හරි. අපි values කීපයක් ගමු. Hi, take a rough paper. Do the calculation. Can you see it? Row it off. Come here. I can see it then. Harin? Do it. Do it fast. That's fine now. Do it. Done. Done. Lian, write the formula. Right. And even the online people, just put a text when you got the answer. Now, did you understood it? For sure? Yes? Good. You have to understand it scientifically, right? Not the method. Because you're all going to be a scientist one day. Yeah, after degree, yes. You'll be doing a research. If you do a research and find something, you're all going to be a scientist one day. And you know, and you know the importance of this is like people are there, you know, the technicians are there who are already using these things. And they don't know any science. They only know how to use it. Multiply gun. That's all. And they don't know the science behind it, right? But if you know the science behind it, you don't need to have a micrometer screw gauge to measure things. Maybe if you don't have a micrometer screw gauge, you can take a screw nail and fix an object, fix an instrument, right? Construct an instrument and use it. Can you do it? If you can do it, that is what makes you a technologist. Get it? So you have to understand the sciences behind it. Otherwise, you will be the same like a technician who follows the methods, right?
So what is the difference between engineer and technology?
There's not much of a gap. They are going more for theoretical things rather than the applications, and you are going
so
more.
They just don't focus like on the practical stuff.
Yes, and you are focusing more on the practical stuff, and don't bring this onto the table now. You have to do the class.
Like the practical side.
Huh?
It's like the practical side.
So it's a good thing, yes. So the practical side is more practiced by the
So we are on
new people.
hands-on experience.
Yes, more than other people. That's the truth. Linear එක කීයක් ගිහලා තියෙනවා? මේක 0.5, this is 1 millimeter. Oh. ඒක division එක 0.5 නේ. For 27 අදම තමයි. How was it set to?
My parents are saying me to do it one year early because I'm.
Yeah, that's fine. You do it early.
They are saying I said that I don't want to lose the first one. I just want to steady and shall be gonna do.
You do what you feel good to do, not what the parents say. Not all the time, you know, not all the time. Don't do all the things that the
My
parents.
parents are saying that first your ITA is me to do is 2026, right?
Yeah.
They are saying me
So
to
that's fine. Even if you can do it, that's fine. You start doing it now and finish it within 1
I
year.
should know my own capacity to do it.
You don't think about it now because you don't know. So you start doing it, and like while doing it, you'll understand if you could do it or not.
So I have to, okay, today we
Jump into the pool and start swimming. That's what I have to say. Don't come to the conclusions before knowing anything. Right? Got the answer? How much is it? How much? 1.6? 1.27. Confirm? Right. So, length equals, what happened? Right? Listen. Length equals, you have to write this formula. Every time you do the calculations, you have to write the formula because additional marks will be given for the formulas. So MSV plus CSV, and the CSV equals LC into CSR, right? Now this is the formula. So what is the MSV? Main scale value is here 0.51 millimeter. So MSV is 1 millimeter. Now the CSV is least count into CSR. Least count is 0.01 millimeter. You have to multiply it by CSR, circle scale reading. So that is the line aligned with the midline here, right? Metana kiyet tinne meka 25, 26, 27. So 27th line is aligned. So it's 27. So you multiply it, how much do you get? 1 plus 0.27. So altogether 1.27 millimeters is the answer. You get the same. Good. So shall we check it? So what is the value? 1.27, right? So that's a gap here, right? That is a gap. So if you place the object like I placed the pen, you get the value of that. Right. So I'm going to measure the, now give something to measure. Okay. I'll take this. You get your look video. I think the phone is better. Right. So I'm going to, now this doesn't give the exact value of that. I'll take this one. Same size. Right. So it doesn't give the exact size, right? Doesn't give the exact size, but we are just taking a prototype. Right. I'm gonna measure it. Right. So I'm going to keep it there and take the thimble scale. I'm rotating the thimble scale until the phone stuck between the anvil and the spindle. Stuck quickly. Not yet. So now you have to use the ratchet, right? I'm going to use the ratchet. The click sound won't come because make a simulation is, let's say now it's stuck, right? Now the phone is stuck, almost in the gap. I'm going to put the lock. Now measure it. You have to write the equation. Write the equation and do the calculations. Why not? Like if you get selected to any of the government universities here you'll be definitely coming out as a scientist. For sure. Done? Good. Done? Done? How much? 4 point? Yeah. 4.4 for the other. The final 4 doesn't come out. 4.4. There's another 4. 4.44, right? Okay. Yeah. The last 4 didn't come out. Stuck in the tongue. Right. So shall we do the calculation? Right. So what is the equation? Length equals MSV, main scale value, plus CSV, circular scale value, and the circular scale value is least count into circular scale reading, right? So what is the MSV here now? 1, 2, 3, 4, right? It's 4 millimeters. Plus the least count is 0.01 millimeter, and into what is the circular scale reading? Number of lines aligned with the circular scale? 1, 2, 3. Is it 40? Ah, yeah, it's 44, right? Because this is 45. Yeah, 44. So it's 44. And the answer will be 4.44 millimeters is the length, right? Right. So the display value. Correct, right? Right. So for the next part, I'm going to bring someone to the board. Yes. I volunteer. Come to do the next calculation. Come. There's a volunteer. Yeah. Come. Come first. Huh? I'll make you famous some other day.
No blur.
Doesn't matter. Right. So give something to measure. Let's say he's measuring. Put the values in. Right. So this is the instrument. We're going to place something. Give me something. Make gamu right? No. So he's going to measure this. Right? Mulimma 0 එකේ තියෙන්න ඕන. All right. Now it's 0. First thing first, listen. You have to check for the 0 errors. Right? You have to check for the 0 errors. What are you doing? Right? You have to check for the 0 errors first. Right? And you have to place the object between the anvil and the spindle. Right? Next day you are not going to sit together there. You are going to come here. No sitting. Right. And you have to take back the thimble. Right. Hurry. Take more. enough. Right. තා චුට්ටක් මෙහෙට ගෙනාව නම් හරි. ඉස්සරහට. තා පොඩ්ඩ ඉස්සරහට ගිහින්. තා චුට්ටක්. Right. Enough, right? Enough, right. So this will be the value. So you have to calculate it. So your friend is going to calculate it here in the board. Right. Write the equation. Sure. Just second, bro. They wanted to enlarge it. Enough? Okay. Right. Right, do the calculation. Now he's doing it. Bro, length equals MSV plus VSV. It is there. Right. MSV plus VSV. CSV and LC into CSR. Right. So what is the MSV value? 1, 2. Is it now listen. Now here is it 3 millimeters or 2.5 millimeters? 3 millimeters. How do you say?
it's aligned.
Because the circular scale have passed the zero value, isn't it? Isn't it? The circular scale have passed the zero value and the 3 millimeter is almost appearing. So it has passed the 3 millimeters and only moved a little bit. So it should be 3 millimeters. Put the millimeters. Oh, that's fine. It's 0.01, isn't it? Please count. The second one, no? This one. The resistance. Right. Right. Huh? Bro, now the millimeters become meters. Right? So you guys are from the same school? You all from the same school? You, herself and him? Yeah? That's why you know each other very well. I can understand that. Done? Is it correct?
Oh, yes.
That is enough, right? So it's correct, right? The main scale is 3 millimeters and it has moved like 7 divisions in the circular scale. So altogether it will be 3.07 millimeters, right? That is correct. And let's take another value. Yeah. Is somebody volunteering now? Come. Do it. You volunteered already. No. Bro. That's fine. You take it after the class, not in the class. Come. Then you come. Guys, listen. So we'll give directly a value, right? So no object have to stuck here. Let's think now the object has stuck here, right? So I put the lock. We have to take the measurement. Shall I just no, I have to annotate this first. Yes. Wait. Alright. Right. So help her with the equation and the values. Now what is the equation? Length equals MSV plus CSV LC into CSR. Yes. So what is the main scale value there? 1, 2, 3, 4, right? 4 millimeters. And the least count is 0.01 millimeters into number of circular scale divisions as aligned is 27. So multiply it, add them together. Brightness එක වැඩි. Nice to that. So I think we still have that issue with the මේකේ brightness එකේ ප්‍රශ්නයක්. board එකේ brightness ප්‍රශ්නයක්. Right? So the next day we'll be discussing the other part. Huh? Yeah. It's 1 p.m. Huh? It wasn't quick. It took almost 2 hours now. Yeah. Took almost 2 hours. So guys, now we'll be discussing the next part. There's also the zero error parts are also there. So we'll be discussing that part the next week and do all the homeworks in the area volume part, right? Remember to do those things, and may try to study together. That's a good thing. When you are studying, try to like study in a group. Either you get together in one place somewhere, or nathang online you may make a group and join online. Like discuss each other and do the calculations. That's a good thing to do. And even join the online people, because they can join online and do the studies together with you guys, right? I wasn't hearing anything. You have to do the homework next week. You didn't have. You have the tutor, right? And it's fine if you can discuss with the friends. Don't discuss this guy. Yeah, no. යාළුවෙක් set කරගන්න. Girls, help the girl. මුල් ටික cover කරගන්න. And you have the recordings anyway. ඒ ටික බලන්න. And you get together with the friends and study. That's a good thing, right? So okay, then see you all in the next Tuesday. Ciao. Huh? 3 p.m. It starts 3 p.m. Stay there. So adios, homies.
So
Bye.
homies එක ඔක විතරද?
Hmm?
දැන් විතර ඉන්නත් homies එක.
Can be. Why not? Let's go. වැඩ කරන්න ඕන. පුතේ මේක නවත්තන්න. හරි. I'm blinking නේ.